We're going to talk briefly about derivatives. You will learn a lot more about this next year, but for now, all you need to know is it tells you the turning points or the stationary points. So the question might ask you to find stationary points of any graph. And remember, what that means is if you have a quadratic graph, so a smiley face, it just means the point at which it turns. Or if you have, like the question we were looking at today, a cubic graph, it's got 2 points where it turns, right? So it's going to have 2 solutions. So finding the derivative is finding the solutions. Now, finding the derivative is shown as dy dx. Don't worry about that. But let's do an example. So if I have y equals, let's say x cubed plus 3x squared minus 4x plus 10. All I'm going to do, now it might sound a little bit tricky at the start, but I promise it's really easy and it's super repetitive. You take the number up the top and you multiply it by the coefficient. So 3 times 1 is just 3. And then you subtract 1 from that. Same thing for the next term. You just do the same thing every time. 2 times whatever the coefficient is. So 2 times 3 is 6. And then subtract 1 from there. So I don't need to write 1, do I? Because it's just implied. Same thing here. I'm going to bring down the power, which if it's not written, it's 1. 1 times 4 is just 4, negative 4. And then 1 minus 1 is 0. So this disappears because remember, anything to the power of 0 is just 1. Remember that rule? So 4 times 1 is 4, and then we don't have to do anything with this term. So this is the derivative of that. And then you solve this to get your coordinates. But let's do another example of this first. All right, so y equals, let's say, 4x cubed minus x squared plus 10x minus 17. All right, same thing. We take the top number and multiply it by the coefficient. So 3 times 4 is 12. And then we subtract 1 from this. And then we've got a minus here. Don't forget about that. 2 times, well, 1 is just 2. And then 2 minus 1 is just 1. We don't need to write that. Same with this. 1 times 10 is just 10. And then 1 minus 1 is 0. So this disappears. So this is the derivative of that. Sorry about that. I've hit the wrong button. Okay, let's keep going. Sorry about that. Okay, so that is how you do basic derivatives. All right, so let's get rid of this. Okay, so they're not going to give you questions quite like that because those are much harder to solve. So let's actually do an example that they will give you. So let's say that I have something like this. So we're looking at cubics, obviously, plus 3x squared, let's say plus 4. All right, so I'm going to find my derivative first, and then I'm going to solve that because we know how to solve quadratics. We don't know how to solve cubics. So I'm going to say that my answer to this is 3 times 1, so 3x squared, subtract 1 from here. Same thing here, 2 times 3 is 6, subtract 1 is just 1, and then this disappears. All right, so now this is the derivative, dy dx. But this now looks like something I know how to solve. And remember, there are multiple ways you can solve it, but the easiest way is pulling out common factors. So when I'm talking about solving it, remember I'm talking about making something equal 0 and then finding my x solutions. So my common factors here, what do I have in common with both terms? Well, they both have a 3 and an x. So then if I divide 3x squared by 3x, I get x. Divide 6x by 3x, I get 2. All right, so if this was a true statement, one of these two things has to equal 0 because anything times 0 is 0. So what does this x have to be to make this true? Well, it has to be 0, right? 3 times 0 would be 0, which would make this 0. What does x have to be to make this section equal 0? Well, it's got to be -2, right? So -2 plus 2 would be 0. So my two solutions are x equals 0 or -2. That is where the two stationary points are of this graph. Let's do another example. All right, this time I'm going to say y equals 3x squared, cubed minus 4x squared, and we'll add 12 to it. All right, so the same thing, I'm going to find my derivative first, dy dx, find my stationary points by doing this. So 3 times 3 this time is 9x, take away 1 from this, minus 2 times 4x, take away 1 is just 1, and this doesn't exist. So now I'm going to say, what do these two things have in common? Well, they don't have any numbers in common, but I can pull out an x. I'm going to make it equal 0. So I have 9x minus 8. So same thing, x has got to be 0. This x has to be 0 for this to be true. And this is the only other problem I have. Remember, it might have been a while since you did this. This one's easy because it's just, there's no number in front of x, but this is more problematic. You take the second number and you put it on top of the first number and you change the sign. So 8/9, right? Because if you times 9 by 8/9, you get 8. Yeah, so 8 minus 8 would be 0. So these are my two solutions. If you can't remember how to do this, let's just quickly have another look at that. If I said x equals 3x minus 5, right, 0 equals that, well then x equals 0 or 5 over 3, and it's positive because I have to change this sign because 3 times 5/3 is going to be 15 over 3. 15 over 3 is 5. 5 minus 5 is 0. Okay, just remember that. It's been quite a while since we looked at that. So these are my two solutions. So find your derivative and then say, all right, what does x have to be to make it equal 0? And those are your stationary points. All right, please do let me know if you want me to do more examples on this. Yeah, good luck.